Alright, let's get into guided practice problems. I accidentally deleted the other one. Alright, so here, okay, as we know, this is, this is the equation that you guys will be using. Okay, you guys watched the previous video on what Q, M, C, and delta T are, but we are going to go over that again. Let's read through the questions. You have, it says, a 9.9 gram sample of metal is placed in cold water. Metal is placed in cold water. If the specific heat capacity of the metal is 0.44 joules per gram degree Celsius, and change in temperature of the metal is negative 57 degrees Celsius, how much energy was released or absorbed by the metal? Okay, now it says the metal was placed in cold water. Okay, so let's see what these are. 9.9 grams. If you watched the previous videos, grams means that should be your mass. So mass is 9.9 grams. You have the specific heat capacity of the metal, which is C, 0.44 joules per gram degree Celsius. And it says the change in temperature of the metal is negative 57 degrees Celsius. So delta T is negative 57 degrees Celsius. Okay, now they want you to find energy, which is given by Q. And as you can see, the formula actually is given for Q. So you do not have to change anything in the formula. Okay, remember how we've manipulated formula for gas laws? Okay, you don't have to do that one right here for this problem. So Q equal to, you have all the values, plug them in, 9.9 grams. 0.44 joules per gram degree Celsius. And as you guys can see, I am also plugging in all the units. And that is because, as you guys can see, grams cancels out. Degree Celsius cancels out. And you are left with joules. And that is the unit for your heat. Okay, and that's how you make sure you use the correct formula. Okay, rest is simple. Just plug the values in. Okay, so here you have 9.9 times 0.44 times negative 57, and you end up with 248.3 joules. But don't forget that you also have that negative. Now, this negative value, as you guys learned from last week, you will have negative energy when the reaction is exothermic. Okay, now you did not see any reaction here. This was basic transfer of energy. Okay, because energy can neither be created nor destroyed. It only changes from one form to the other. Okay, for example, you have food, you eat food. Food had potential energy. When it burns in your body, it releases, it changes the form of energy, and with that energy, you can move around. So that's your kinetic energy. You can do work. Okay, so that's mechanical energy, like it changes forms. Okay, so this negative suggests that it is exothermic. Okay, all right, moving on to the next problem. Next problem says you have a large piece of metal which is heated and placed in ice water. It was heated, that means its temperature is probably high, and it was placed in ice water. The metal releases energy. Okay, and how much energy? that much. So here, write your formula. Q equals to mc delta T. Okay, it released energy. Okay, when energy is released, it's exothermic, so the value should be negative 1023 joules. Okay, and it says if the temperature of the metal changes by negative 44 degrees Celsius and the specific heat capacity of the metal is 0.91, what is the mass of the metal? Okay, so here, negative 44, that's your change in temperature. Delta T equals to negative 44 degrees Celsius. Okay, specific heat of the metal is 0.91. C equals to 0.91 joules per gram degree Celsius. They want you to find your mass, which is right here. Okay, all right. Now, if in case right here I gave exothermic negative, right? But in the question, let's say if it just says releases, you need to know that you should put a negative in front of this number. Okay, because if you don't, your mass is going to be negative. And as everybody knows, mass can never be negative. Okay, for it to be zero, it should not exist. Okay, so let's see. Mass, you need to figure out the formula for mass. Right now the formula is for Q. That means you have to get rid of masses, friends, right here at the moment. Okay, C delta T, cross them out. M equals to Q over C delta T. Your Q is 1023 joules, right? C is 0.91 joules per gram degree Celsius. And your change in temperature is negative 44 degrees Celsius. Joules cross out, degrees Celsius cross out. You end up with a gram. And what is mass measured in? Voila, gram. Okay, all right, now we just plug it in. Also, you guys can see the negative right here, these cancel as well. Okay, negative times negative, positive. Negative divided by negative is also positive. Okay, be careful when you plug in your numbers. So 1023, divide that by 0.91, and divide that by 0.44. Or sorry, that's not 0.44, it's 44. Okay, and you all end up with 25.5 grams. That is the mass of your metal. Okay, now also remember, if the metal is heated and placed in ice water, that means the initial temperature of the metal is always larger than the final temperature. Okay, it's like you holding the ice on your palm. Okay, if you guys can try it right now. Go to your fridge, okay, get a ice cube, okay, place it on your palm. You feel cold because you are losing heat. Obviously, the temperature of your palm is higher than the temperature of the ice. So the energy flows from your body to the ice, which results in you feeling cold because you are losing energy, and the ice melts because it's gaining energy. Okay? Hope that helps a little bit. Okay, moving on. Last one. Right here says a 5.4 gram piece of metal is placed in ice water. If the metal releases 453 joules of energy, what is the change in temperature of the metal? And the specific heat capacity of metal is given. Again, your formula is Q equals to mc delta T. Okay, here mass is given 5.4 grams. The energy is given in joules. Q equals to 453 joules. And then you need to figure out the change in temperature with your C being 0.344 joules per gram degrees Celsius. Okay, right? Okay, we did miss out a piece. It says metal releases energy. If it's releasing, it's exothermic. And if it's exothermic, it should be negative. Okay? All right. Now here you need to solve for your formula because you need to figure out delta T. And the formula is actually just giving you Q right now. Divide both sides by MC. Cross them out. Delta T equals to Q over MC. Right? So that's your formula. Delta T equals to Q over MC. Q is negative 453 joules. Again, you guys see it. I'm putting all of the units because I want to make sure that my formula is correct at the end. Mass is 5.4 grams and your C is 0.344 joule per gram degrees Celsius. Okay? All right, here. Can I cancel the joules out? Obviously. Grams out? Yeah, for sure. And you're left with degrees Celsius. And temperatures measured in degrees Celsius. Okay? All right, next is just plug and chug. Okay, you have 453 negative, of course. Divide that by 5.4 and divide that by 0.344 and you end up with negative 243.9 degrees Celsius, which means that the initial temperature of the metal is way higher than the final temperature of the metal. Okay, and you guys can know this because delta T is TF minus TI. If the difference is negative, right, that means the initial number is way higher. If the difference is positive, that means the final temperature will be higher. Okay, hope this helps. You do have a quiz, but the quiz is not timed, so make sure you take your time. Okay, actually practice because it helps you.